Our today's first problem is let W1 and W2 be finite dimensional subspaces of a vector space V. If dimension of W1 equals to 2, dimension of W2 equals to 2, dimension of W1 plus W2 equals to 3, then we have to evaluate dimension of W1 intersection W2. We have a formula here is dimension of W1 plus dimension of W2 will be equals to dimension of W1 plus W2 plus dimension of this W1 intersection W2. So substitute the value of dimension of W1, W2 and dimension of W1 plus W2 in this formula. We have dimension of W1 intersection W2 will be dimension of W1 plus dimension of W2 minus dimension of W1 plus W2, that is 2 plus 2 minus 3, that will be come out as 1. So the correct answer will be option number 1. Next question is the dimension of vector space spanned by 1 minus 2 3 minus 1 and 1 1 minus 2 3 is, let's write this in a matrix form. We have 1 minus 2 3 and minus 1 1 1 minus 2 and 3. Since the determinant is not equals to 0, that's why the dimension of this vector space will be 2 because the number of rows in this are 2. Next question is, this is similar to the previous one. We have 3 minus 6, 3 minus 9, 2 minus 2, 4 minus 2 and 6. This question is similar to the previous one. Let's take 3 common from this row and 2 common from this row. We have 6 here and this will be 1 minus 2, 1 minus 3 and minus 1, 2 and 1 and 3 here. Now perform R2 minus R1, R2 plus R1. We have 6 into 1 minus 2, 1 minus 3 or 0 0 0 0. Okay, and the number of non-zero row in this determinant or in this matrix is 1. That's why the dimension of this vector space is 1. This is the simplest method. What we have to do is we have to write the given vectors in the matrix form, okay, and then try to reduce it. The number of non-zero rows will be the dimension of that particular vector space. Next question is, in the vector space R cube, the coordinate vector of 3 5 minus 2 relative to the ordered basis 1 0 0 0 1 0 and 0 0 1 is, okay. Now try to write it as 3 5 minus 2 equals to A1 into 1 0 0, A2 plus A2 into 0 1 0 and plus A3 into 0 0 1. It will come out A1 plus A2, A1 comma A2 comma A3. That means A1 equals to 3, A2 equals to minus 5 and A3 equals to minus 2. So the correct answer is option number 2. Next question is, each set of n plus 1 elements or more vectors of a finite dimensional vector space Vf of dimension is linearly dependent. If we have a vector space of dimension n, then each set of n plus 1 or more element of finite dimensional vector space will be linearly dependent. The answer will be n. Next question is, if W1 and W2 are two subspaces of finite dimensional vector space Vf, then dimension of W1 plus W2 plus dimension of W1 intersection W2 will be equals to dimension of 1 plus dimension of W2. Next question is, let V be a vector space of M cross N matrices over a field F, then dimension of V. We have initially solve a question of the form when we have a matrix of 2 by 2 order. We have seen the standard basis for that kind of a matrix, and that's why we know that in any m by n matrices over a field, we have the dimension of V will be always will be m into n. That is, the correct answer will be mn. Next question, in a basis set, zero vector cannot be an element, should be at least an element, may or may not be an element. We have seen this kind of a problem in many questions, as we know that zero vector cannot be an element, because if we have a zero vector, then we don't have a linearly independent set. That's why we cannot have zero vector as an element. Next question is, for each finite dimensional vector space, there exists a basis. Next question is, dimension of Q over Q when it has a dimension 4. Let's find it out. We have a field Q root 3, root 2. It constructed by starting with Q and adjoining all the root vectors of the polynomial, because this Q root 2 will have a polynomial of the form x square minus 2, and this Q root 3 will have the polynomial of form x root minus 3, because root 2 is the solution of this polynomial and root 3 is the solution of this polynomial. Okay, so the basis or the linear combination of this kind of a set will be of the form a plus b root 2 plus c plus d root 2 into root 3. It will be a plus b root 2 plus c root 3 plus d root 6, or you can say the basis for this q over q will be 1 comma root 2 comma root 3 comma root 6. That's why the dimension of this will be 4, because we have 4 elements. So the correct answer will be 4.